Hi guys, today we're starting Unit 4, our study of rational functions. So when you see a rational function, you will see two different polynomials that are being divided, because remember, ratio just means that we are dividing two different things. So it'll look kind of like this example here. So the first part we're going to do is just simplifying rational expressions. So there are no equal sign in here. There's no operation, multiply, divide, addition, and subtraction other than the division that we see in the actual rational function. So our steps for this, you probably want to write this down. Remember, you can pause and rewind as needed. But step one is going to be to factor. I know how much you guys are all looking forward to doing some more factoring. And then step two, you're going to reduce using your common factors. So we're going to try to find common factors that are in the numerator, the top, and then the denominator, the bottom. A very, very important reminder is these addition and subtraction signs that are in the polynomials are gluing the separate terms of that polynomial together. So you cannot, like if I look at 1 plus 3 divided by 4 minus 3, even though these 3's are common, I can't just say that this 3 divided by this 3 reduces to 1, because that would leave me with 1 over 4. And if I actually work this problem out, I would get 1 plus 3 is 4. 4 minus 3 is 1. So the answer to this one should be 4. So make sure that you are not crossing out if there's addition and subtraction. You need matching polynomials completely. So that should make sense when we get into this. All right, so let's look at example number 1. So it says negative 2ab squared all cubed. So if I factor that, I am going to take this and write, come on, you're going to write with me, negative 2ab, and I want to do that 3 times because it's there 3 times, right? Negative 2ab all over 20a and then 4b's. So I'm going to look for any common factors that are in my numerator and denominator. So negative 2, negative 2, and negative 2. Negative 2 times negative 2 is positive 4, times another negative 2 would be negative 8. If I want to go over here and think about negative 8 divided by 20, I know that 4 goes into both of them. So negative 8 divided by 4 is actually negative 2, and 20 divided by 4 is 5. So that's going to reduce to negative 2 over 5. And now I want to come and look for some other factors. So I can take one of these a's divided one of these a's. A over a is just 1, so I do not need to worry about multiplying by 1. Those are essentially gone because they become a form of 1. And then I can take out this b with this b reduces to 1. Another b can be reduced. Any top with any bottom as long as they are exactly matching. Notice that these are joined by multiplication, so I don't have to worry about like the addition that I'll see like in number 2. All right, so now I just need to figure out what's left. So I have, let me just grab a different color. I have this a left and this a, so a times a would give me a squared. I have 2b's here, so that's b squared, and then nothing left on my bottom. So the answer for this one would be negative 2a squared b squared all over 5. All right, let's look at the next example. So I am going to delete this. See all these tricks I've been working on to try to help you guys. Hopefully this is a little better than the last one. So first step is going to be to factor. So this one is joined by multiplication and division. So you cannot just do x squared over x squared. That breaks all rules of mathematics. So you don't want to do that. You actually have to factor so that they're joined by multiplication first. All right, so this is a normal trinomial. So I'm just thinking multiply to be negative 6 and add to be 1. So my numbers are going to be positive 3 and negative 2. And then if I look on the bottom, I want to multiply to be negative 27 and add to be negative 6. So I can do negative 9 and positive 3. All right, step 2, look for any common factors. So common factors are going to be the same exact polynomial on the top and the bottom. So these x plus 3's can cancel out, and I'd be left with x minus 2 over x minus 9. All right, That is my answer. I cannot cross out those other x's because they're glued together by that subtraction sign. So I would only be able to do those if they were the same exact. Let's look at number 3. So I want to factor first. So if I look at my numerator, I do have a GCF of 2. So I'm going to take out a 2, and that would leave me with x squared minus 4. X squared minus 4 is a difference of perfect squares, so that can be factored even more. So x plus 2 and x minus 2 becomes my difference of squares from x squared minus 4. And then this one on the bottom is your guys' favorite type. So I'm actually going to take this and work it over here because I have some space. So this is when I do bottoms up. Remember, you are totally welcome to do any method that works for you. Bottoms up's just best for me. So I multiply my A and my C. Multiply now to give me -4. Add to give me 3 would mean that I would have +4 and -3. I want to put back that 2 that I multiplied. So to undo multiplying, I'm going to divide and then reduce and move bottoms up. 4 divided by 2 would make that factor x plus 2. 1 divided by 2 does not reduce, so I'm stuck with 2 as a bottom, so that bottom moves up. So my factors of that one are going to be x plus 2 and 2x minus 1. Step 2, look for common factors. So this exactly matches that, so that goes away. And now I'm just going to write my answer. So I have 2x minus 2, you can leave it in factored form, over 2x minus 1. If you want, you can go ahead and distribute that, and then you get 2x minus 4 over 2x minus 1. Just make sure that you do not get tempted to cross out these 2x's because they're glued together to the other part.